Weather today? Nope. We are going on an absolutely incredible adventure following the epic journey of a single raindrop, from the ground all the way up to the sky and right back down again. So let's dive in. Have you ever really thought about it? What is a raindrop's journey? We see rain all the time, right? It's just there. But there's a whole story behind every single drop. And that's what we're going to do today. We're going to break down that super complex journey into a simple and honestly fascinating story. Okay, so before we blast off on this journey, let's get the absolute basics down. At its core, what is rain? It's just water, right? Well, yeah. More specifically, it's liquid water that forms from this invisible gas up in the atmosphere, water vapor, once it gets heavy enough for good old gravity to pull it down. That's the end game. But believe me, the journey is where all the cool stuff happens. And you know what? This whole massive global process, we can actually break it down into just 4 main steps. Think of it like a roadmap for our little raindrop's big adventure. So here they are. First, you've got evaporation, then condensation. After that comes coalescence, and finally, precipitation. Each one is like a critical chapter in this story, from a daring escape to an epic fall. So, let's start right at the beginning. All right, step 1, we're calling this the Great Escape, and you'll see why in a second. This is the moment our little water molecule basically gets its one-way ticket up into the sky. So, how does it happen? It all kicks off with the sun. The sun's energy just beams down, warming up the water everywhere. We're talking oceans, lakes, rivers, even the dampness in the soil. This heat is like a supercharge. It gives the water molecules so much energy that they literally break free from their liquid form and transform into an invisible gas called water vapor. And just like that, they've escaped, rising higher and higher into the atmosphere. Okay, so our water vapor molecule has made its great escape. It's now floating free up in the atmosphere. But it's not going to be alone for long. This next part of the journey is all about building a community, about joining forces to create something way bigger than any single molecule, a cloud. And the key ingredient here? It's all about temperature. See, as that warm water vapor keeps rising, the air around it gets colder and colder. That chill basically forces the vapor to do a U-turn. It changes its state again, going from that invisible gas back into teeny tiny visible droplets of liquid water. And that critical switchback? That's what we call condensation. But here's a really cool detail you might not know. These little water droplets, they can't just pop into existence out of thin air, no way. They need something to grab onto, like a little anchor point. So they cling to all these microscopic particles that are just floating around up there. We're talking dust, smoke, pollen, you name it. These tiny specks act like cloud seeds. Without them, it would be almost impossible to form a cloud. So yeah, these little bits of dust and stuff, they're kind of the secret ingredient to the whole recipe. So now we've got a cloud, right? A huge collection of these microscopic droplets. But they're still way, way too light to fall. This is where the next step, coalescence, comes into play. You have to imagine it's like a chaotic party inside that cloud. It's a constant swirl of activity. All these tiny droplets are bumping into each other, crashing, merging, and with every single collision, they get a little bigger and a little heavier. And this brings us to the tipping point. The droplets keep bumping and merging, growing and growing, until they hit a very specific critical size, about 0.5 millimeter across. Now, I know that sounds ridiculously tiny to us, but in the world of a cloud, that is the magic number. Because once a droplet hits that size, everything is about to change. You could say our droplet has finally grown up. It's teamed up with countless others, it's reached that critical weight, and now it's time for the final and totally inevitable part of its journey. So picture this. Inside the cloud, you've got these upward air currents constantly pushing up, which is what keeps all the tiny, lightweight droplets floating. It's like a constant battle. But once our droplet hits that 0.5 millimeter mark, it's just too heavy. The air currents can't hold it up any longer. Gravity finally wins, and it pulls that droplet all the way down to Earth as rain. And that, in a nutshell, is precipitation. And there you have it. Our raindrop has made it, completing its incredible journey and falling back down to the ground. But here's the thing. The story doesn't end here. Not at all. In fact, it's really just getting ready to start all over again. And this, right here, is why it all matters so much. You take that one single drop, and you multiply it by trillions and trillions, and what you get is an absolutely vital part of the Earth's water cycle. This constant journey, from the ground to the sky and back again, is how our planet gets almost all of its fresh water. It's what feeds the plants, fills our rivers, and pretty much sustains all life as we know it. So honestly, the next time you're outside and you feel a few drops of rain, maybe think about that incredible journey. It's just a cool reminder that even the smallest things in nature are part of this huge, beautiful, and absolutely essential story. And it really makes you wonder, doesn't it? If every single raindrop has a story, what will the next one tell?